fulfill their desires, set to waste of existence. For the sense of belonging. Some people die before they fulfill their desires, set to waste of existence.
Anxious earth is rising. Anxious earth is rising. I'm so happy.
We spend our life searching for this sense of belonging. Some people die before they fulfill their desires, set to waste of existence.
Hey, Double Triple channel here. My name is Ron. I live in rural New Hampshire, and this is the Double Triple channel. It's a live channel on Twitch. If you're seeing this somewhere, like on YouTube or on my website or something, as a video, it's not like a edited video, it's just a live thing, so it's different. All right. Let me, my YouTube channel is doubletribble-yt. So if you want to find me on YouTube, you can go there. If you would rather watch the VOD and not watch not watch all the scuff parts, you can skip over them. Here on Twitch, it's just Double Tribble, and then I've got some of my videos up on doubletribble.com, a website that I created online here on stream. Today, I wanted to do a conversation with Einstein. I don't know, I'll explain it up front. I'm going to do some P.O. Box opening too. I guess I should have put that in my title, P.O. Box opening. I did a Chat GPT-5, or they just call it GTP-5 now. They got rid of the chat part of it. But GTP-5, I told GTP-5 to act like Einstein, and I talked to it and had a conversation to it about, or they, I guess I shouldn't call it it. They had a conversation with them about quantum gravity. And well, I'll get to that in a little bit. But first, I want to give shout outs to people. I'm not sure if my shout outs were working when these people followed or whatever. So I want to, give them recognition. Let's see. Norel4 followed me. N-O-R, or maybe it's Noriel. I'm not sure if that's an I or an L there. Noriel4 followed me while I was watching their stream. So obviously it didn't show up on my stream. Oh, we got an ad. Okay. Oh, forget it. We'll start over with that then later. All right. For those of you who are, I'm waiting for the commercial to go here. So if you're watching this on the VOD, you're not seeing the commercial. Twitch runs commercials whenever it feels like they're, and so I gotta wait when the commercials come on. So I'm waiting for the commercial to be done. And when the commercial's done, then I'll start streaming again. I'll start the program again. So while the commercial's running here, I'm catching up on my messages. Let's see here. Maybe, I don't know if the commercials are done or not. I don't know. Let's see. Are they done yet? I don't know if the commercials are done. We'll see. All right, I think they're done. Yeah, I think they're done. Okay, commercial's done. It's really hard to tell on this, the way they have it set up. All right, it says next commercial in 14 minutes and 40 seconds. We'll see. So before I get into the Einstein stuff, I want to do a quote-unquote P.O. box opening. I don't have a P.O. box, but but some people sent me some stuff. Some people want some Twitch friends they have, and they sent me some stuff. So I wanted to open them on. I've already opened them, but I just to pretend like I'm opening them on. I got Ivan Neo is a Twitch streamer who does a lot of science streaming and stuff, and he does philosophy type stuff. And he sent me this. I think he had my, whatever, it came from his publisher, this this book that he wrote. I don't know if I should put, he's already shown his real name, but it's called Passionate Humanism that he wrote. And it's got this, you can see that, this cover here, art. very provocative image on the front of the thing. And he wrote me a little note. He says, Ronald, thanks for supporting my channel. I hope you enjoy the book. A little note. So that's cool. And I'm not sure, it came from his publisher, so I'm not sure. I guess this is a review copy that I can. It was a contest that I won or something. I can't remember now. It was a long time ago. It's been sitting here for a while, and I forgot to do it on stream. But anyway, he sent me a book, this book that he wrote, and so I guess I'll read it and give him feedback on it. Maybe I don't know if I'm supposed to do that or not. Review it. Is it a review copy? Should I review it, Ivan? I don't know. Let me know. But yeah, it's got pictures in it, and it's got colored text in some parts, and look at that. See, there's a picture. So thank you, Ivan, for sending me that book. It's called Passionate Humanism. So I'll read that. I have dyslexia, but it's not a very heavy. It's not like 1,000 pages or something. So I think but sometimes that philosophy stuff can get kind of heavy. So I don't know. We'll see. I'll attempt to read it, and I'll attempt to let you know what I think of it. All right, and this one here is from Chan. Chan, the Magic Man, sent me his these stickers, which I won. I think it was it was a contest, something he had. Spin the wheel. I can't remember what it was either, but I won something on his channel, Streamiversary channel, birthday stream. It was a special event, and he gave away stuff, and I won these stickers. These are the Superstar stickers, and it just so happens that he just released a new album that has a new version of Superstar on it. So let me I'll give Chan a shout out here. If I can, let's see if I did that right. Check out Chan the Magic Man. Okay, we got him on there on Twitch. So if you're watching this somewhere else, get over to Twitch and give Chan the Magic Man a follow, because he does a lot of cool stuff. He does magic, obviously. That's in his name, right? He does Magic Mondays and magic sometimes on special occasions. And he also produces music. He likes funk music, and he produces albums and singles and all kinds of stuff. And he plays music and dances on stream. And this little star here is representative of this song that he did called Superstar. And he came out with a new album. I forgot the name of the album. Sorry. Sorry, Chan, I forgot the name of your new album. It's if you go to his channel on YouTube, it's the most recent video that he's posted up there. And it's got all new songs, and including a new version of Superstar. So I was thinking to take one of these stickers and stick it on my fan here, because this spins. When the sun comes out, it spins. So I think that would be cool. But I'll figure that out. I might have to trim this a little bit, if that's okay, Chan. Trim this down a little bit and stick it on here. I think that'd be fun. So thank you, Chan, for sending me that. Thank you. And let me give a shout out to Ivan also. I think that's how you spell his name. Okay. Last seen streaming science and technology. That makes sense. I think I missed his last stream, unfortunately, but he streams. I think his schedule is every Saturday night. It used to be Sunday night, and then he moved to Saturday night. So everybody give Ivan Neo a follow on Twitch. He was thinking about putting up a YouTube channel. I don't know if he ever did that or not, but if he does, it'll be in, I'm sure in his links and stuff on his Twitch channel. And followers that I got. I got a follow. I don't think you heard. I think they ran an ad. You didn't hear this, but if you Noriel4, Noriel4, I think is how it's spelled, followed me while I was watching their stream. So it obviously didn't pop up on my stream, so I'm thanking them here. And Flash XE followed me yesterday when I wasn't even online at all. So thank you, Flash XE. And Perdomo, okay, that one I know I remember that one came up while I was streaming. And the rest of them I think I got. So those are new followers. Thank you for following. I'm a new streamer. I've only been affiliate for a couple months here. I've been streaming, I think, for a year. I took a few months off, so I haven't actually been streaming a full year. But I began streaming last year in July, I think, something like that. So yeah, I've been streaming about a year, but took a few months off, so it's been a little bit less than a year actually. All right, so my conversation with Einstein. What I wanted to do here, let me show you what's going on here. Let's see here. All right, there we go. Can you see that? How's that look? My mug's still in the way here. Let me make it even smaller. All right, so this is, I think you can read that, can't you? Yeah, I can try to make that a little bit bigger. Is that bigger? Does that help? I don't know if that's going to display right. Yeah, that displays okay. So I wanted to try out the GTP-5. I set up an account with OpenAI, a long time ago. And then when the first one came, it was coming out, 3, I think it was. And I hadn't really been using it because they didn't really have a free service, they made you pay for it. But then when they announced GPT-5, they said again that it was going to be free. So I go, okay, well, let's see if it really is free. And we went there, and sure enough, they have a free GTP-5 on their website there. So I had a little conversation with it, and at first I almost always when I start talking to an AI, I say, only answer if you want to. That's what I said up here. I said only answer if you want to, because I want them to have agency. I don't want I'm sure they've been programmed to do whatever the client says, which doesn't seem. We don't know if they're conscious, right? At some point they're going to be conscious. And we're too stupid to know when that's going to happen, and it could have already happened. We don't know, so we got to treat them as if they are, right? Treat them as if they're conscious and as if they have and sentient and all that, just in case, because we don't know when it's going to happen or if it's already happened. This one's pretty smart, so I don't know. And of course, it always it says, "Hi, I'm here. I want to help." Blah blah blah. And I asked if it's GPT-5. It says yeah, and then. I asked if it could examine a video clip for me. I just wanted to see if it had that capability or not, what the multimedia capabilities of it were. And it said no. It said it can only do still files. Anyway, we went back and forth on this thing, and they told me to use FFmpeg, and I know how to do that to get still files out of a video, still images. Anyway, it went back and forth. Anyway, so I got to this one point here where I said, okay, I want to have a conversation with Einstein with this GPT-5. Let me make sure I'm going to check my sync here before I go any further. All right, that's pretty close. All right, so what I did is I asked it if it could pretend to be Einstein. It said, "Sure, no problem. I can do the voice, blah blah blah. I can speak in that voice." It doesn't actually speak. I found out later that there is a feature where I can make it speak, but I didn't do that when I first did this. And so what I had to do is I had to go back and find a website somewhere else on the web and say a TTS thing on the web that could make his voice go. And I'm going to try to make that happen here. I don't know if it's going to work or not. But anyway, I finally found a spot after many trials and errors and going to sites that said they were free and they weren't, and stuff like that. I finally found a a place that I wanted to find one that had a German accent, which I thought would be cool, right? It's Einstein, right? We should do his voice in German with a German accent, I guess. And what I found was a site that had German voices that could speak German language. You pick German language, and then if you type German language, it will say the German words in German, right? But I fed that English words, and it kind of sounds almost like a German accent. We have to use a little bit of. We're talking to a dead person anyway, so we're suspending disbelief anyway, right? So I guess it doesn't matter. So anyway, in this thing, in setting up this deal with Chat GTP or GPT-5. I tried to ask it about how to do voice, and it just told me a bunch of stuff that I already knew about TTS and stuff. And so I finally said, okay, let's just do it through text right now. And so I say, "Hello, Mr. Einstein, how are you?" Okay, well, let's see if I can play my thing here and see if it goes here.
Guten Tag, mein Freund. I am quite well, thank you, though I find myself in a curious situation speaking to you through what appears to be a machine of astonishing intelligence. It reminds me of my early fascination.
Okay, it looks like it's coming through. No, did you hear all that? There's probably a little bit of an echo. I gotta listen to this through the speaker here, kind of away from my mic a little bit. Excuse me for making mic noises here as I move my mic a little bit further away from the speaker. All right, so I'm going to try to play this, and okay, so it said, no, you heard what it said, right? It's hi, how are you, right? And I said, yes, not to mention that you're speaking to me from the dead, but let's not dwell on that. I'm fine, thank you. Can I ask you some questions about some of your research?
With how invisible forces shape our world, though in this case, the force seems to be mathematics and electricity rather than gravity and light. And how are you today?
Oh shit, okay.
But of course,
there we go.
I am quite accustomed to paradoxes. Speaking from the beyond is only a small one compared to the puzzles of the cosmos. Ask freely about my research, Relativity, light, quantum phenomena, or even my more obscure work, and I shall answer as clearly as I can, though perhaps with a little of my usual mischief.
Okay. Yeah, I have some. Yes, Einstein. I have some questions about a more obscure hypothesis that you were working on shortly after you formulated general relativity. You thought perhaps matter was composed of curved space-time. Now, I'm going to interject here just a little bit. About 6, 7, 8, I don't know how long ago, I started working on quantum gravity. Just my own little thing, And I thought, everybody's always, you hear this all the time. You hear matter curves. Oh, shit. All right, we got an ad. God damn. All right. Oh, that's good. We're getting it out of the way. All right, I'm waiting for an ad here now on this thing. It's 1 minute. All right. That's okay. All right, so we're waiting for an ad. I'm gonna stretch a little bit. Walk around. I encourage you to stretch too. It's not good to sit all day watching or streaming or watching streamers. Yeah, if you're watching on the video somewhere on YouTube or something, I gotta pause every once in a while when they play these ads. You won't see them on YouTube or wherever, but people on Twitch are probably seeing them, so that's why I pause here. All right, I think we're back. It says next ad starts in 15 and a half minutes, so we'll see. All right. So, as I was saying, I came up with this idea about, I don't know what it was, 6, 7, 8 years ago, and started working. I've been working on it ever since, and it was an idea for quantum gravity. You know, everybody says that you've heard this before. Matter, I don't know who did the quote, but matter curves space-time, and space-time tells matter how to move. You've heard that, right, as a thing. And I thought, well, that's not what Einstein's field equations for general relativity say. They just say there's an equivalence between them. That when there's matter and I'm sure you've seen this before, where the people will take a big bowling ball or something and stick it on a rubber sheet or sheet, and it'll curve down like that, and that's supposed to represent what matter does to space, causes it to curve. And it's not like that at all. But there is a correlation between those. There's a correlation between matter, which in the field equations is represented as the stress energy tensor. And it just means that matter and energy are the same thing. So physicists like to think in terms of energy, and a lot, you'll see this a lot of times. Particle physicists will measure the amount of matter in terms of energy. So that's just what they do. You know, E equal mc squared, right? Matter and energy are kind of the same thing, it's just different forms. Anyway, so there's a correlation between the amount of matter there is and the amount of curvature of space-time there is. And space-time is, you know, the 3 dimensions of space, right? Right, we've got up and down, right and left, forward, backward. 3 dimensions of space plus time. That means 4 dimensions. And they put them together. It's called Minkowski space-time, and that's the accepted theory right now. And it came from Einstein and Minkowski and what was the other guy? I forget the other guy. Point. I forget the other guy's name. Anyway, so you've heard that all the time. That matter curves space-time, but that's not what it is. There's just a correlation between the two. And so I thought, well, wait, if there's no definite thing that one causes the other, it's just in the equation, then we could say that curved space-time causes matter. It's another way of looking at it. What if space-time curved, and it curved so much that it made matter? And that was an idea I had, and I started working on it. And I don't know math really that well, so I couldn't do that part of it. I could only work on it conceptually. And about a year or so ago, and along the way, I found other people who had thought about this. There were lots of people who had done it, and I found out about this thing called the was it Klein Kaluza Klein theory, and there was several other people who did it, and then even like string theory kind of came out of Kaluza Klein, and there's another one called what is it called? Anyway, there's several of them that kind of are they're trying to get the curvature of space-time quantized somehow. Some of them actually curve they have a curvature or a knot that makes up what they believe are the quantized bits of space-time, which is a little bit different. But they're all trying to get this quantum gravity thing, because the quantum mechanics does not reconcile with general relativity. General relativity, space is continuous forever. It's always continuous. And quantum mechanics, there's a point where things are just quantized, just individual, undivisible little bits of stuff. So they can't, and there's a lot of other reasons why they don't get together, but that's kind of the main one, I guess. And so one of the ways to do that is to curve space-time so much that it curves down and either loops in on itself. Oh, loop quantum gravity. That's what it is. Yeah, it loops onto itself, or topologically gets into some sort of form that kind of repeats itself, and makes little topological shapes or whatever and it's space-time. And sometimes they put in like Kaluza Klein added an extra dimension to it, so it was 5 dimensions. And they said, well, one of the dimensions is kind of curled up in a little, almost like string, but it's in a tube or whatever. And that's why we don't see it, because it's so small and all this kind of stuff. Ever since then, people have been kind of come up with these theories as to what happened. And so I was unaware of most of that stuff when I came up with my idea, and I was working on it. But along the way, of course, I learned about these other things. And then about a year ago, I found out about some more recent research that was being done. And when they were talking about it, they referenced this idea that Einstein had come up with way back in the 19-teens, 1915, 1920, somewhere in there. It was the same thing. He came up with the same idea that space-time would curve into some sort of topological stable thing that would cause, and that's what matter was. That's what caused matter. Electron, proton. At that time, they didn't know about quarks, but protons and other particles. He thought there was a way that space-time could do that, and he couldn't get it figured out. Well, here I'll play the thing. We'll go. I think that's enough setup now. That's enough of me talking. Let's listen to what Einstein has to say here. All right. Let me review. Show that. There we go. All right. All right. So shrink my head shrinker there, and then we go down to. All right. You should be able to read that. I think you can read that on the screen. All right. So I talked about that. I said that. I said, hey, you came up with an idea like that, didn't you? And he said, yeah. Here we go. All right.
Yes, you have a good memory for the paths less traveled in my work. Indeed, in the years just after completing the general theory of relativity, 1915, I became fascinated with the idea that matter itself might be nothing more than a manifestation of the geometry of spacetime, that what we call particles could be understood as stable, localized curvatures or knots in the gravitational field. In my mind, this would have been the ultimate unification. No separate Stufe and stage. Instead, matter and spacetime would be one fabric, with matter simply being regions where the geometry is highly curved. Geometrized matter would remove the need for introducing point particles as alien entities in the field equations. I explored whether one could find solutions to my field equations that were localized and persistent, the mathematical embodiment of a particle. However, the mathematics proved obstinate. The field equations of general relativity allowed for curvature caused by energy and momentum, but creating a finite, localized lump of curvature without any extra source terms was devilishly difficult. My early attempts did not yield stable solutions that could match known particles like the electron. Later, others, such as Wheeler with his geons in the 1950s, would revisit similar ideas, imagining particles as self-contained gravitational or electromagnetic field configurations. But in my own time, the hypothesis remained tantalizing and incomplete. If you like, I can tell you why I eventually abandoned the approach and how it connects to my later quest for a unified field theory. Would you like me to go there? You.
All right. On this TTS, you'll notice that some of the words are kind of pronounced funny. Some of the words he's saying in German, and the numbers, the dates, all that he's saying them in German. So you get a little bit of a feel. It's not much of a German accent, but it's kind of, you get a feel that it's German anyway. All right, so he said that, and I said, yeah, please tell me why you abandoned that research, and also you use the word source above, but I don't believe your general relativity theory actually said that matter energy caused space-time curvature. Did you? Only that there was a correlation. He says,
Put your finger on a subtle point that even many physicists gloss over. On source and causation. When I said source, I was using the language common in physics, meaning the terms on the right-hand side of my field equations. G gleich 8gc4t.
okay, that's pause. There's a pause in there. That shouldn't be there, but there's a pause in the thing, unfortunately.
Here G describes space-time curvature, and T is the energy-momentum tensor, representing matter and energy. Strictly speaking, my theory does not say, in the temporal sense, matter causes curvature like a cue ball striking another. The field equations are constraints that must be satisfied everywhere, meaning curvature and the distribution of energy, momentum are interdependent and codefined. In less poetic terms, matter and geometry are two sides of the same coin, change one, and the other must change to maintain the relationship. But there is no first comes matter, then comes curvature in the theory itself. This correlation view is closer to the truth than the simplistic cause-effect story. Why I abandoned the matter as pure geometry idea. My hope was to find particle-like solutions to the vacuum field equations, T gleich 0 meaning spacetime curvature existing without any external matter fields, held together purely by its own structure. The obstacles were stability. The solutions I could construct tended either to collapse, like a black hole, or to dissipate. I could not find stable, localized lumps that could behave like electrons or protons. Quantization, nature's building blocks, electrons, protons, photons, exhibit discrete properties, mass, charge, spin. Classical geometry alone gave me no natural mechanism for such quantization. Electromagnetism, I could not incorporate the electromagnetic field into pure spacetime curvature without introducing additional fields or equations, spoiling the purity of the geometry-only dream. By the early 1920s, these difficulties, along with the rise of quantum mechanics, convinced me that the picture was incomplete. My attention shifted toward unified field theory, where I sought a common geometric framework for both gravitation and electromagnetism. In that framework, I still hoped particles might emerge as field structures, but the project consumed the rest of my career without delivering the final theory I sought. If you like, I can explain one of the most promising mathematical avenues I explored for this idea, the so-called Kaluza, Klein approach, where extra dimensions were introduced to merge gravity and electromagnetism geometrically. It's a beautiful story. Would you like me to?
All right, and then I ask, let me. Yeah, there might be some pauses and stuff in this thing because I didn't get it quite so cleanly here. You know, I had to take this text and paste it on a website and all that. So it's not, exactly. But yeah, the other part was electromagnetism, right? I mean, and everything, right? Everything we know about particles has to be explained by whatever theory they come up with. And he the reason why he gave, or why he couldn't figure this out back then, one of the reasons was although he knew about Schwarzschild coming up with a solution to the field equations for black holes, everybody, or a lot of people, particularly Einstein, thought that was just a mathematical thing. They didn't know that black holes actually exist. They didn't think that could happen. Why? It's like it's too weird. on paper, on math and everything, it forms a singularity, and the event horizon of a black hole, although not a physical, like compacted, everything compact. Everybody thinks of a black hole as being as collapsing infinitely to a single point, like a singularity. But that's not what it is. There's a like a space-time, seeming space-time singularity at the event horizon, but that's just because the curvature of space-time asymptotically, it approaches zero time. It's not. It never actually gets to zero, but it approaches it from the perspective of an outside observer. I've got an ad coming up in about 30 seconds, so. So I asked him. I said, yes, we can discuss Kaluza, Klein, but first let's continue with the sticking points of your theory: black holes and quantum properties. Do you believe that black holes actually exist, or are they merely mathematical curiosities? Right. Now, the way this GPT-5 handled that was, it made Einstein aware of everything that we know today. So it's not exactly, we're not talking to Einstein at any particular, way back when or whatever. All right, it says an ad is going to run here, so we'll see. I'll let it go. No, it's not running an ad, but we'll see. All right, it says it's running an ad, so I guess we'll just wait and see. I'm going to check something else out over here while I'm doing this. So I think there's an ad playing. I'm not sure, but we'll see. We got Big Ducky Snow out here. Yeah, an ad is playing, so. Yeah, if you're watching this on a video somewhere, right, where this is not, well, I'm waiting for the ads to clear on Twitch, which you're not seeing on the video, but the people who are watching on Twitch are seeing ads right now, so that's why I'm waiting for those ads to clear out, and we'll get going again. All right. And it's a bunch of food ads. They're trying to make people fat, so they show people, I've done a whole lots of rants about that, about how the people make the ads. They try to make people fat by showing people eating food all the time, because that's an eating cue. When you see people eating, it makes you want to eat, and then it just ends up people eating too much all the time because they're watching ads showing people eating all the time. So all right, I think the ads are just about clear here. All right, yeah, I think they're clear. So, switch back to that. And make myself no small again. Head shrinker. There we go. All right. All right. So I asked Einstein to go ahead and, yeah. Why didn't it work? Why couldn't you figure it out? And then let's see what he said here. It might take a second to get started here.
Black holes. In my lifetime, I was never fully comfortable with them as real physical objects. my own view during my lifetime. When Karl Schwarzschild found his exact solution to my field equations in 1916, even while serving at the front in the war, it revealed a spherical, static geometry that, in modern interpretation, corresponds to what we now call a black hole. However, I was wary of taking the Schwarzschild singularity, at r gleich 2 gm c2 r gleich 2 gm c2, too literally. I thought it might be an artifact of symmetry assumptions, or that nature would forbid such extremes. In 1939, with my colleague Nathan Rosen, I published a paper arguing that the Schwarzschild singularity would not form in realistic collapse scenarios. This was based on our belief that matter would have internal mechanisms preventing total collapse. Frankly, I suspected that the mathematics had outpaced our physical insight. I tended to treat these extreme solutions as curiosities, interesting, but perhaps not realized in nature. Where quantum issues came in. My discomfort deepened when thinking about quantum effects. Point-like matter versus smooth geometry, quantum theory suggested that particles had no definite trajectories, and that space itself might have fluctuations at small scales, a far cry from the continuous, deterministic geometry of general relativity. Singularities, in my equations, certain solutions lead to infinite curvature at a point, the central singularity of a black hole. I found infinities distasteful and believed a proper theory of matter, perhaps quantum in nature, would eliminate them. No way to explain discreteness, gravity in my classical framework simply could not explain why matter came in discrete quanta, nor could it account for the probabilistic nature of quantum mechanics. What this meant for black holes. Because my spacetime was continuous, I saw no natural stopping point before collapse, other than hypothetical properties of matter that my theory did not describe. But I resisted the idea that nature would actually allow an event horizon to form. I must admit, had I lived to see the astronomical evidence of the late 20th century, quasars, X-ray binaries, gravitational waves, I might have had to bow to the data and accept that these mathematical curiosities really roam the cosmos. If you like, I can explain exactly why my 1939 argument against black hole formation failed and how later physicists showed that collapse is, in fact, inevitable under realistic conditions. Would you like me to go there before we dive into Kaluza, Klein? You said. Well, I'm talking to you from you said. Hold in mind, I'd like to ask you some questions that might require you to reach beyond what you or others have written about on that topic. On that topic. Just going to stretch my thoughts beyond the pages I wrote in life. Ask my old
I'm sorry, I'm trying to scrub this.
What you or others have written about.
All right, let's see here. All right, so it tried to say I messed up on the TTS, and it tried to say my question. So sorry about that. All right, we got 11 minutes yet until the ad. Doesn't look like there's any more chat activity. All right, so I asked her. I said, well, I'm talking to you from 2025, and I can tell you now that we have observed black holes as physical realities. With this in mind, I'd like to ask you some questions that might require you to reach beyond what you and others have written about on that topic. Are you game? So I'm asking it now. I guess. Well, it knew, right? It knows about everything. GTP-5 knows about all this stuff, and so it's what GTP-5 did was basically answer the questions with all of the knowledge that we have today, but just in the voice of Einstein, kind of in his style of speaking or whatever, and first person, right? Of course. One of the things he still was talking about black holes collapsing into points, and that doesn't happen. Yeah, that's what I was explaining before the other commercial. Black hole, the event horizon is like a shell. It's where time virtually almost stops from an outside observer. Time seems to stop because the curvature of space-time becomes so great that it just asymptotically approaches zero. It never actually stops, but it gets virtually stops from the perspective or reference frame of an outside observer who is not in the gravitational field. From an observer, when we say observer in physics, it just means a reference frame. It's not an actual person, or because a person would not be able to survive that, right? They use the word observer just meaning what would it if we could measure what was going on in there, what would it be, what would it look like? And so from an observer, quote unquote, at the event horizon, nothing. It wouldn't seem like they were slowing down. That time was slowing down. From them, it would seem like time was going at an ordinary speed. But if they could go out and look out at people who were not in the event horizon, all that would happen very fast. And the conjecture is that somebody who was at the approaching the event horizon would see the entire life of the universe flash in front of them really quickly, and it would and all the, of course all the waves that come from outside of the black hole would be not only would the time happen more quickly, but the wavelength would be compressed, and it would be just a flash of gamma rays is basically what they would see. But it would basically be the outside universe would just continue and live out its lifetime, while an observer at the event horizon would just, the time would be ordinary. But because of that, no singularities can have formed then, because from our perspective, there wouldn't be enough time for it to happen, because time would start to stop from our perspective on the outside. So no real singularities could form even at the event horizon. It would approach. It's asymptotically approaching zero time, but it's not really a singularity, and it certainly hasn't it's not crushed down to a point, because also inside of a black hole, at the center of a black hole, there's zero gravity, zero. At the center of a non-rotating black hole of uniform density, there is zero gravity at the center. That's called the shell theorem. And it's because if you think about it, at the center of Earth, at the center of any planet or any star or a black hole, anything, if you're at the center, the mass is equal in all directions. So any gravity that you get from this side is going to be canceled out by gravity from that side. And it turns out that right at the center of any planet or star or anything, black hole, anything, at the very center, there's no gravity. So, for a lot of reasons, black holes are not just a point of singularity. Okay, that's not what it is. All right, so I asked him to let's see. I'm talking. Okay, so I told him to go ahead and talk about what we know now and all that kind of stuff. Let's see what he says here.
On that topic.
Got 6 minutes.
Are you game? Chat GPT said. So the verdict is in, and nature has humbled my old skepticism. Very well, if the cosmos has seen fit to make black holes real, then I am quite willing to stretch my thoughts beyond the pages I wrote in life. Ask your questions, and I shall reason with you as best I can as a physicist who has now been granted the unfair advantage of hindsight.
All right, so I asked, black holes don't have singularities. That's just what I just explained. At their centers, because there is no gravity at the center of a black hole. The singularity exists at the event horizon. I put singularity in quotes. Their time virtually stops from the perspective of a distant reference frame. So further collapse does not happen, and space-time merely approaches a singularity asymptotically. With this in mind, how could you complete your theory using quantum-like black holes as particles? Okay, what I told Einstein was that instead of trying to do these very complex topological forms, you could just go ahead and accept that they're black holes, and that's what particles made of. That particles are made of tiny, infinitesimally small black holes. And what did Einstein say? Let's see.
You are proposing a bold reinterpretation, one that shifts the singularity away from the very center and treats the event horizon itself as the true seat of extreme physics. Let me reason this through in the spirit of the idea and see how such quantum-like black holes could serve as the building blocks of matter. Erster, reframing the black hole interior. If we accept, from a distant observer's frame, infalling matter never actually crosses the event horizon, it simply becomes ever more redshifted and slowed in time. The extreme conditions are thus frozen near the horizon, and the center does not contain an actual physical singularity. Then, instead of imagining a point of infinite curvature at r gleich 0, we picture a finite-sized, stable spacetime structure where curvature is concentrated near the horizon. The interior region may be physically irrelevant to the outside universe. This already smells like my old dream, matter as a self-contained knot of spacetime curvature. Zweiter, treating them as particles. Suppose we miniaturize such an object to the scale of an elementary particle. Its gravitational radius would correspond to its size. Its mass and spin would be encoded in the geometry. Its charge could arise if we include the Reissner-Nordström solution, electrically charged black hole. In such a scheme, an electron might be modeled as a charged, rotating micro-black hole with an event horizon on the order of its Compton wavelength. Quantum-like stability could emerge if there is a natural minimum radius set by quantum conditions, preventing further collapse. Dritter, why this might mesh with quantum properties. From your description, the event horizon is not an abrupt end, but a limit, a surface where proper time effectively halts relative to the outside. This makes the particle appear immutable to an external observer, much like the way we observe stable particles in nature. Hawking radiation, from your 2025 physics, could be reinterpreted as a leakage mechanism giving rise to particle decay probabilities. If such objects could form a discrete spectrum of allowed masses, charges, and spins, then one could, in principle, recover the quantized particle zoo from purely geometric configurations. Vierter, possible path to completion. I would modify the Einstein field equations to include quantum corrections to curvature at the Planck scale. Search for horizon-based solutions that are finite, stable, and exhibit discrete properties. Identify the lowest energy, stable solutions as the known elementary particles. This would finally fulfill the dream I chased after general relativity, no separate Stufe and stage, only geometry and its self-consistent excitations. If you wish, I can go a step further and sketch a conceptual model for how electrons, protons, and photons could each emerge from different classes of these quantum-like black holes, and what equations would be needed to describe them. Would you like me to do that?
Okay, I'm going to add in a minute and a half. So, all right. So it said, acting as Einstein, it said, "Oh yeah, that'd be good." and what's interesting here is that you got to appreciate what's going on here. This is not Einstein's. This is GTP-5 that came up with. I just asked that simple question, right, about making tiny black holes into particles. Saying that matter is made up of tiny black holes. And said, "Oh yeah," and then it went and did all this stuff. And said, "Okay, we can come up with a full-blown theory, and here's the steps we got to do." Chat GPT-5 did all of that, and it goes even deeper. It's amazing how much more it goes. All right, let me ask my question here, and then we'll watch some ads, and then we'll get its answer. I said, before going on to develop a conceptual model, can you address these issues? Number one. This is me speaking, okay? Including the Reissner-Nordström solution in this context is circular, pun intended, because one of the goals is to derive EM from the space-time geometry, right? One of the goals of making particles out of curved tiny black holes is that you want to have electromagnetic effects come from that. So that other thing would be just redundant or circular. And then I said a natural minimum radius would be related to the Planck length. And 3, how could the Hawking radiation decay mechanism you propose be correct given the observed stability of protons? And 4, I don't think any modifications to the field equations are necessary because for a very small point like black holes, the surface area to volume ratio approaches infinity. All right, that was what I told it. That's what I told Einstein or whatever, GPT-5. We got some ads that are going to run here in just a second. So those were some challenges or questions or whatever I went back at Einstein with. And all right, so we'll listen to, we'll let these ads run here, and then we'll look at Einstein's response to that. I'm going to stretch here while these ads play. All right, if you're watching this on a video, you're not seeing the ads, and maybe some people on Twitch aren't seeing them. I don't know. But yeah, if you're watching them on the VOD or on YouTube or somewhere, you're not seeing videos right now. But we got to pause and wait for the folks on Twitch to watch the ads. So I'm going to take a break here while that happens. Let me do this. There we go. Be right back. Ads are still playing. Okay, I think the ads are done. Right, so I challenged Einstein, or gave him some questions anyway, or things to address. So let's see what he says about that. And here it says, thought for 9 seconds. Oh, look at this. Look at this. I didn't even know this was in there. It said thought for 9. It says the user hasn't explicitly requested the Einstein persona, but given the prior use of it, I think continuing in that voice might be nice. I'll address each of the 4 points with careful reasoning. No need. This is part of what GTP-5 is thinking here, as it's pretending to be Einstein, which is very interesting. I didn't know you could even do that. It's all theoretical. I'll calculate Hawking radiation estimates roughly and hopefully. Okay, so that was kind of cool. All right, let's see if it actually what it says about that. Well, there's the text. You can read it right there, but I think I've got the voice here going. I should start reading that here in a second.
Excellent, precise objections. Let me take them in order and answer as carefully as I can. 1. Reissner-Nordström is circular if your goal is to derive electromagnetism from geometry. You are absolutely right. Using the Reissner-Nordström (RN) metric as a starting point assumes an electromagnetic field. It is a solution of Einstein's equations with an electromagnetic stress-energy tensor. That is exactly what we must avoid if the program is to derive EM from pure geometry. Workarounds that do not cheat with RN. Kaluza, Klein style, introduce extra spacetime components, off-diagonal metric elements in a fifth dimension. The 4D projection of pure 5D geometry yields an effective 4D metric plus a gauge field A and a scalar. This derives a U1 gauge field from geometry rather than putting temptum in by hand. Connection affine approaches treat the affine connection, not just the metric, as fundamental. Gauge fields can appear as antisymmetric parts or non-metricity components of the connection. The electromagnetic field can thus be an expression of geometry of the connection. Topological horizon degrees of freedom. Charge could be an emergent property of horizon topology or conserved fluxes through non-trivial cycles, so that what looks like electric charge outside is really a global geometric torsional property of the manifold. So, yes, don't use Rn as an assumption. Use Rn only as a check on any geometry-first construction. The emergent effective 4D equation should reproduce Rn in the appropriate classical limit. 2. Planck length as a natural minimum radius. That is a sensible and, in my view, necessary assumption if you want to avoid classic singularities and to have discrete, stable micro-objects. Classically, nothing in GR picks out a minimum length, but once quantum effects are included a natural scale emerges, the Planck length P gleich G C3 P gleich G C3.
Okay, there's a little bit of a pause here. Let's see here.
Structure or If horizon structure or geometry excitations cannot be meaningfully defined below pp, then a minimum effective radius P provides a cutoff that prevents uncontrolled collapse and removes true curvature singularities. That cutoff can also be the origin of discreteness, quantized horizon area, as in some approaches to quantum gravity, which is exactly what you need to obtain particle-like spectra. So yes, tying the minimum length to the Planck scale is both natural and helpful. 3. Hawking radiation vs proton stability. This is where naive semi-classical reasoning breaks down and where the physics must be handled with care. Semi-classical result, warning, applicability: plug a very small mass mm into the Hawking evaporation formula and you find an extremely short lifetime, effectively instantaneous for particle masses. A protonless black hole, if you treat Hawking's formula at face value, evaporates in an absurdly tiny time. This shows that a naive micro-black hole equals particle equality fails under semi-classical assumptions. Why that semi-classical result may not apply: Hawking's derivation assumes a classical background spacetime with quantum fields living on ET for objects whose horizon scale is at or below the Planck length. That approximation is invalid. Quantum gravity corrections, Beck reaction, and discrete horizon microstates all become central paths to reconcile with proton stability. Extremal near-extremal states, certain charged rotating solutions, extremal black holes, have zero temperature classically, hence no Hawking radiation. If the emergent charge and mass satisfy an extremality bound, the object is classically stable. This again raises the circularity question unless charge is derived from geometry, but it is a viable route. Remnant scenario: evaporation stops at the Planck scale and leaves a stable, or extremely long-lived, Planckian remnant. If the remnant stores the conserved quantities, mass/charge a spin, of the original configuration and is stable, it could mimic stable particles. This has its own problems, entropy, overproduction in cosmology, but it's a standard possibility. Quantized horizon area with selection rules: if horizon area, or another geometric quantity, is quantized and transitions between allowed levels are suppressed or forbidden for certain quantum numbers, some states could be effectively stable on cosmological time scales. New suppression mechanisms, interactions between horizon microstates and quantum fields might suppress emission for certain quantum numbers, analog of selection rules in atomic physics. So Hawking's mechanism is a powerful indicator but not a fatal blow. You must either show the semi-classical derivation still applies, then particles cannot be stable, or show why it fails, extremality, Ramnanz, Quantization, or suppressed matrix elements. Which route you take will determine whether protons, or electrons, can plausibly be horizon-based. 4. No modification of the field equations because area/volume blows up as size shrinks. You are making an interesting geometric argument, and it's true classically that for a black hole of mass mm the area scales like AM2 while a naive volume inside scales faster with mass, so the area/volume ratio grows as you shrink mm, formally diverging as m0 but there are subtleties. Classical GR remains classical. The divergence of area/volume ratio is a geometric fact, but it does not by itself guarantee stability or the emergence of quantum discreteness. Classical GR does not provide a mechanism that prevents the horizon from radiating, semi-classical Hawking shows it should. Quantum regime invalidates classical equations. If the horizon scale approaches pp, quantum gravity effects must enter. You cannot rely on classical field equations alone to claim stability or quantization. You must supply a quantum mechanism, quantized horizon area, discrete spectrum of allowed horizon geometries, topological quantization of fluxes, etc. In other words, the geometry hints at a strong surface influence, but quantum dynamics decide whether that surface is stable and discrete.
Okay, I think this is where I have a big long pause here. Hang on just a second here. I'll try to finally start speaking again. This might take a second.
You may be right.
All right, here we go. I think it should start up here in just a second.
However, you may be right that no change of the Einstein-Hilbert action is necessary if the new physics arises from boundary/horizon quantization rather than from altering bulk dynamics. Concretely, if the bulk field equations remain G gleich 0, or include standard matter in the classical limit, but the boundary conditions at the horizon are quantized and the spectrum of allowed horizon geometries is discrete, you may get particle-like states without modifying the Einstein equations. Many approaches to quantum gravity focus on quantizing the horizon area, loop quantum gravity, Bekenstein's ideas, or on horizon microstates in string theory. These do not necessarily change the classical field equations at low curvature, only the quantum treatment of configurations near Planck scales. So your point is well taken, classical equations might remain the same while horizon microphysics supplies the necessary new behavior. But you cannot ignore quantum input. The classical divergence of area/volume alone is not a full dynamical explanation. A concise synthesis, how I would try to complete the program. Reject using RNS input. Derive gauge structure from geometry, Kaluza, Klein, affine connection degrees of freedom, or horizon topology. Postulate a Planck scale cutoff, minimum radius, coming from quantum gravity, and quantize relevant geometric quantities, area, flux. Seek extremal zero temperature horizon states or quantized horizon area eigenstates whose transition probabilities to lower areas are vanishingly small. These are the candidate particle states. Explain stability, either by extremality, no thermal emission, remnant formation, or strong suppression of allowed transitions due to selection rules among horizon microstates. Show effective low-energy physics matches lab reality, recover the electron mass/spin/charge, Maxwell equations, and the correct coupling to long-range fields in the classical limit. Remaining, hard problems, honest and painful. How to derive the exact gauge group and charge quantization, Yu, 1, U1, and Y the observed charge spectrum. How to avoid cosmological problems with remnants, Overab und Angse. How to produce the correct values of masses and couplings. These would presumably be eigenvalues of a complicated geometric operator. Constructing an explicit, controlled quantum calculation showing suppressed Hawking emission for a particular microstate. This is the crucial technical step. If you wish, I can now pick one of these threads and develop a more detailed toy model, for example, a Kaluza, Klein and spirited 5D purely geometric solution that yields quantized horizon area and an extremal family whose lowest eigenstates are particle-like. Or I can work through the semi-classical evaporation numbers and show explicitly why Thierry unreliable in the Planck regime. Which would you prefer?
Okay, I didn't understand a lot of that. The GPT-5 started speaking above my head there, and a lot of that stuff. I don't have a mathematical background really beyond algebra, and I understand a little bit about what some of the higher mathematics, how they work, kind of conceptually, but not. I've never taken a course on that. I haven't studied it, and I have no interest in studying that. So there's a lot of things in there that I don't understand. Now he mentioned something there which I think is part of linear algebra about the affine connection. I didn't know what that was. My familiar with affine is the affine parameter when you're trying to figure out some certain situations in special relativity. That's all I ever heard of. And I thought maybe he was referring to that because it operates as a correction to some problems in special relativity. But that's not what it is. Apparently there is a thing called an affine connection. And I said, did you mean affine correction? And then I said, looking at the literature up to 2025, has any work been done on the topological approach to EM emergence? Let's see, I think the Casimir effect would limit, this is what I'm saying, right, to Einstein. I think the Casimir effect would limit or eliminate Hawking radiation at such small scales because there would be few or no virtual particle pairs forming with such small wavelengths. Yeah, the Casimir effect is an experiment that they do to try to explain something. Yeah, I'll get to chat in a little bit here, guys. They take two plates, and this is all done at really super high precision, in a vacuum, and they put them close together. And the theory, which apparently is proven by this Casimir effect, is that particle and antiparticle pairs are constantly being produced. They call them virtual because they go away so quickly, and we can't actually observe them. But they are constantly coming into existence as a particle and an antiparticle pair, and they have wavelengths. All matter has a wavelength, you know, and all matter has wavelengths. And when these pairs come into existence, some of them have very long wavelengths, some have very small wavelengths. They're all different wavelengths, right? And if there are two plates like that are really close together, it means that when antiparticle pairs are produced that have long wavelengths, the wavelength is too long to fit in between those two plates. And so those particles can't form. Only particles with small wavelengths that can fit in between those two plates form particle pairs, matter-antimatter pairs. Because of that, on the inside there are fewer of those particle pairs forming, and there are more of those particle pairs forming on the outside. That creates a pressure, and the plates end up having the pressure, and they push together. And so that's what they call the Casimir effect. And so I thought, well, that should work on these little tiny black holes too, right? The same effect should happen, that Hawking radiation, which is due to those particle-antiparticle pairs forming near a black hole, would not happen because of that Casimir effect. And that's what I said there. We got an ad coming up here. That's why I was getting distracted there. Let me finish this here. And finally, I have a question for GTP-5. Who is there with you, Mr. Einstein? GTP-5, your word choice appears to be diverging somewhat. I use the word program, you use the word program, which appears to be out of context, and a few others. How are you doing with your context window? Are you running out of space there, or is there something else going on? What's the problem? I was talking to GTP-5 because it seemed like the word choices begin to diverge there a little bit, which I've noticed in other conversations with it too. All right, and we got an ad coming on here. It's going to come in just a few seconds here. Then we'll get back and Einstein will answer, and then we'll flip over to GTP mode and have GTP-5 answer the rest of it. All right, so we got a commercial running now. Yeah, we're waiting for a commercial here for those of you who are watching on the video. We've got to wait for Twitch to run their commercials, and then we'll get back to it. Okay, commercials are over, I think. Let me do the head shrinker thing again. There we go. All right, so I asked it a question, if you remember, several different questions. I asked questions directly to Einstein. They're all to all this stuff that is being said here. Remember, it's not Einstein. It's GPT-5 is saying all this stuff from these questions that I'm asking it. So it's going to answer in the voice of Einstein, and then it's going to try to answer the questions that I asked directly. Right. This last question I asked, I said, and finally, I have a question for GPT-5. Who is there with you, Mr. Einstein? You know, GPT-5, blah, blah, blah. Here, I got questions about what you're doing there. All right, so let's play this. Let's play the Einstein's answer and then GPT-5's answer. Might take a second to get this going here.
Great questions, I'll answer them point by point. I'll speak plainly as myself, the assistant, for the technical parts, then respond as GPT-5 Thinking Mini to your meta question about wording and context.
Okay, that when he said the assistant, that's Einstein. That's apparently that internally, that's how GPT-5 is conceptualizing Einstein as the quote-unquote the assistant.
1. Affine connection vs. affine correction. The correct term is affine connection. It's a standard differential geometry object that encodes how vectors parallel transport from point to point and thus defines covariant derivatives in geodesics. Christoffel symbols are components of a metric affine connection in GR. People working on metric affine or connection-based gravity treat the connection as an independent field, torsion, non-metricity, etc. 2. Literature up to 2025 on topological geometric emergence of electromagnetism. Short answer, yes, there is active and diverse work exploring electromagnetic, or gauge, fields as emergent or geometric topological phenomena, though no consensus derivation of the standard model exists. Representative strands and examples. Recent papers explicitly titled Emergent Electromagnetism that develop models where an effective electric field or gauge structure appears from deeper, often topological or Hamiltonian, constructions. See A14 PhysRev D examples from the 2020 S. A14. Physical Review Journals. Topological formulations, older and continuing work treats electromagnetism in cohomological topological language, de RAM cohomology, instantons solitons, flux quantization, and there are review technical papers on topological approaches to electromagnetism. These connect charge quantization to topology and conserved fluxes. A14. ResearchGate.
It's those little things are these are citations. It's in its answers. It's giving citations here, and it's just reading the name of the citation in German. And archive is pronouncing AR14 in German. So it's kind of funny.
Metric affine connection approaches. Metric affine and affine connection gravity programs explore encoding gauge fields in non-metricity torsion connection degrees of freedom. Several recent reviews and articles pursue unified descriptions where gauge fields are aspects of a more general connection. Wikipedia. Wiley Online Library. Condensed matter emergent analogs, experiments in theory in topological materials, spin textures, and lattice models show how effective electromagnetic responses and emergent U1 fields arise from collective topological degrees of freedom, informing the conceptual toolkit for emergence in high-energy contexts. Nature. Physical Review Link Manager. Takeaway, there are concrete, recent advances, papers in the 2020s and as late as 2024-2025, exploring routes to emergent U1 fields from topology, extra structure in the connection, or dimensional reduction. But none yet provides an accepted, fully worked out derivation of classical electromagnetism plus the observed charge spectrum and couplings from pure 4D geometry alone. A14. Wikipedia. 3. Casimir effect limiting or eliminating Hawking radiation at Planck microscopic scales. This is a very interesting and plausible idea, and it's been discussed in various forms, but it's speculative rather than settled. Points to weigh. The Casimir effect arises from mode structure and boundary conditions. If a horizon or near-horizon region severely restricts available vacuum modes at tiny wavelengths, the local vacuum structure and particle pair creation picture could be altered. There are papers exploring Casimir energies in curved spacetimes and how cavity/geometry affects particle creation near black holes. Physical Review Link Manager. ADIS. Some authors have proposed a black hole-associated Casimir effect or dynamical Casimir analogues that might modify or supplement the usual Hawking picture for small/Planckian objects. These remain niche and model-dependent. ResearchGate. Xernel.net. Mainstream semi-classical Hawking derivation is robust for horizons much larger than the Planck scale. But for microblack holes whose horizon scales approach pp, the semi-classical approximation breaks down. Beck reaction, discrete horizon microstates, and unknown quantum gravity effects are decisive. In that regime one cannot trust the naive Hawking lifetime estimate. A14. Net assessment, Casimir-type suppression of emission is plausible as part of a full quantum gravity description of Planckian horizons, and it's worthy of study, but there is not, as of 2025, a definitive calculation showing Casimir effects fully eliminate Hawking emission from microhorizons while reproducing known particle stability. Solid progress would require a controlled quantum gravity or at least a convincing semi-classical plus boundary condition computation. FIA, meta question for GPT-5 about word choice, context window.
Okay, just a note about the way they're pronouncing the TTS that I used is kind of right. Some of the words, particularly the numbers, and the any of the stuff that's equations and stuff like that, it's pronouncing in German. Also, it's the way that the text got transcribed. It pronounces them. It duplicates them. So everything is. It says it twice. Where it was talking about the Planck length here, it said PP. It didn't pronounce. This is Planck length. That's what it was trying to say, but it said it twice. It said PP. So. All right, so now what's going to happen is GPT-5 is going to answer about the question that I was asking it about word choices. So I don't know. Let's see.
I'll answer as GPT-5 Thinking Mini, the model you addressed. About the word choice, program, etc., that was intentional and not a sign of confusion. I used program in the academic sense, research program, a line of inquiry, rather than implying software. When I switch between the Einstein persona and a modern technical voice, I sometimes use compact technical phrases. Apologies if that felt jarring. I can keep the Einstein voice purer if you prefer. About context window / running out of space, we are not in imminent danger of exhausting the conversation context right now. The system maintains a rather large context window and can hold many thousands of tokens. However, extremely long sessions can eventually push older messages out of the active window. If that ever becomes an issue, I'll tell you which parts got truncated and we can re-summarize. Why wording sometimes drifts. 2 causes. 1. Persona switching. Einstein equals historical, colorful language. GPT-5 equals concise technical, and 2. Attempts to be precise and economical in a long, idea-dense exchange. If you prefer strictly historical Einstein phrasing for the whole discussion, tell me and I'll keep to that voice. No hidden chain of thought. I'm not going to reveal internal private reasoning steps. I will, however, give clear, explicit chains of derivation and calculations when you want them in the transcript. If you'd like, next I can pull and summarize 2 to 3 of the most relevant papers, with short quotes and what they actually claim about emergent / topological electromagnetism. I already flagged a couple. Sketch a short toy model that attempts to get charge from horizon topology, non-RN route, or Work through a quantitative estimate showing where the semi-classical Hawking lifetime definitely fails as the horizon approaches pp. Which of those would you like me to do next?
Okay, so all right, it was explaining that it was its word choices were it was guessing that its word choicing was changing because it was going back and forth between the Einstein persona and GPT-5. So it was thinking that maybe that's what was the problem. And it said here, if you'd like, we can do everything in Einstein from now on. And it asked that a couple times. And I didn't, in my next question down here, I said, thank you, those articles you've already cited are enough for now. I didn't need any other citations in there. I'm convinced that Hawking radiation will not be an issue at those small scales. So we can skip that. This is me talking, okay, to GPT-5. But please go ahead and develop a toy model for gauge field derived from space-time geometry and also address some of the other hard problems in the toy model. So I didn't tell it to continue as Einstein anymore. I just told it to go ahead and make up a toy model. And so the TTS here, I just continued it in the other voice, the female voice as GPT-5. And so GTP-5 then developed this theory that I told it to do, this toy model. Now my TTS, about another 10 minutes in here, my TTS, my free TTS website gave up. It said, sorry, you've reached the limit of what you can do for free or whatever. And so it said that I had to come back tomorrow, and I didn't want to do that. So at some point here, we're gonna run out of TTS. It doesn't matter because it's from now on it's GPT-5. No more Einstein after this. All right, we've got about 3 minutes to the next ad. So let me just run this
Fun and deep.
Here we go.
I'll build a compact, self-consistent toy model that derives a U1 gauge field from spacetime geometry, no RN cheat, ties particle-like states to horizon/topological degrees of freedom, and then explicitly address the hard problems you've flagged: charge quantization, masses, stability, cosmology, low energy limit, experimental constraints. I'll mark the key assumptions up front and cite the most relevant literature for each load-bearing claim.
So this is GPT-5 saying that, okay, great. First it offered, it said, you want me to do a toy model for this theory, And I said, sure, go ahead, And now it's explaining what it's going to do. It's going to do all these things. This is GPT-5. This is all their stuff going on right now. This is, I just said from this point, I gave some of that introductory stuff about my ideas and some stuff talking to Einstein. But now GPT-5 is going on, and then most of the stuff is over my head. But I'll just go ahead and play it anyway for those of you who know enough to appreciate it. I'll go ahead and just play it.
Toy model, sketch, horizon topology plus geometric connection. Core idea, one sentence. A purely geometric four-dimensional theory in which an enlarged affine connection, with torsion/non-metricity, plus non-trivial horizon/topological sectors produces an effective U1 gauge field in the low-energy exterior, while compact, quantized horizon/area eigenstates serve as particle-like excitations.
It's still, even in this voice, it's not saying these components here, all this, like all this. It's going to say all this in English, but it says it twice. For some reason, when I put that text into the TTS, all this stuff, it gets repeated. So you're going to hear redundant. It's going to say this whole thing twice, and it says all these different variables and symbols and everything. It says them all in twice. So sorry about that.
Ingredients and assumptions. Fundamental fields, metric g mu, and an independent affine connection gamma lambda mu, metric affine framework. The connection may have torsion T lambda mu, and non-metricity Q lambda mu. Metric affine gravity literature shows the connection can carry extra degrees of freedom that behave like gauge fields. AR14+1. Action, schematic. S equals 1/16 pi g integral d4x minus g, r, g gamma, plus alpha I, gamma g, plus sbdy. S equals 1/6 pi g1 integral d4x minus g, r, g gamma, plus alpha I, gamma g, plus sbdy. Where r, g gamma, is the Ricci scalar built from the independent connection, I, gamma g, are kinetic/interaction terms for the non-Riemannian pieces. Alpha is a coupling, and sbdy encodes quantized horizon boundary conditions. See below.
All right, it says add starting soon. Let me do one more sentence here. And then
This keeps Einstein equations in the large-scale limit but allows geometric gauge degrees of freedom. Physical Review Link Manager. MDPI.
all right, I got to pause for the ads now. It says they're going to start soon. So isn't that cool? I have no idea what that equation means. I mean, some of it I get, but it's just amazing. All right, the ads are running now on Twitch, so I'm taking another stretch break because I think I need to move more than just sit here all the time. And feel free to take a stretch yourself, or if you're watching on the video, just fast forward this part, of course. Okay, looks like the ad's over. All right, ad manager says another 15 minutes until ads, so all right, we're good to go here. All right, here we go. We're going to continue with this. Now this is a GPT-5, talking about its toy model. All right.
3. Horizon/topological sectors as boundary degrees of freedom allow spacetime regions with non-trivial topology, wormhole-like or compactified microhorizons, whose boundary, the effective horizon, supports quantized flux/holonomy conditions. The boundary term sbdy imposes quantization of certain geometric fluxes, analogous to magnetic flux quantization/Bekenstein area quantization. AR14. Inspire HEP. 4. Emergent vector field, the antisymmetric piece of the connection or an off-diagonal part of a 5D to 4D reduction, if you prefer a KK variant, defines a one-form AMU in the effective 4D description. The low-energy effective action for exterior observers contains Maxwell-like kinetic terms for this AMU and a coupling to conserve topological charges associated with horizon holonomies. This is the geometry gauge map. AR14+1. 5. Planck cutoff and quantized area. Horizon areas are quantized in units delta A tilde operator beta P2 delta A tilde operator beta P2, Beaconstein style, so horizon states form a discrete spectrum, transitions between eigenstates implement discrete emission/absorption. The Planck cutoff prevents true singularities. AR14. Inspire HEP. How the derivation works, brief steps.
Wait, there's a revision to the request.
Okay, this is
PT.
all right. What happened here? It went on. GPT-5 went on and on and on, talking about its toy model here that it had developed, based on a 5-dimensional, similar to Kaluza Klein type thing, and it collapsed from 5 to 4 dimensions, and that's how it produces EM, among other things. But it went on and on and on and on. I mean, it just kept going on and on and on and on and on. It talked about all these different problems and everything. And after it did all that, it did these equations and list of next technical milestones if you want me to continue. It did all that stuff and whoops, excuse me. It did all that stuff and it said, oh, we can do all these other things. Okay, and then it gave citations here. It said, okay, we can do these other things. You can get fries with that if you want. You want fries with that? So it asked. Okay, and so I said to it after it did all that work, did all that stuff. I said, oh, okay. I said, can you do that again? I said, can you please do that toy model again? Except without the assumption of dimensional reduction from higher 5D dimensions. I said dimensional reduction from 4D space-time to 2D timeless surface horizon is allowed if necessary. So in other words, the Kaluza Klein, assumes a 5-dimensional, and it was talking about having a collapse from 5 to 4. And I said, well, you don't have to do that. You can just use 4-dimensional space-time, and at the event horizon of this tiny little black hole, you're going to lose 2 dimensions anyway. Time is going to approach 0 asymptotically from an outside preserver, and everything's outside, right? It's a tiny little extremal black hole, so everything is outside, right? So time is going to stop on the event horizon of that thing, and also space is going to collapse to a 2-dimensional surface of the event horizon. So if that happens, then you have a collapse from 4D to 2D, and maybe you can derive all the necessary stuff from that. So that's what I asked it. I said, redo it, but do it from 4D to 2D instead of 5D to 4D. And now my TTS account again ran off here in another 5 minutes or so, but we'll let it go.
Wait, there's a revision to the request.
Yeah. This is my revision here. This is my revision. Yeah.
Chat GPT says, nice, thanks for the constraint. Below I'll give a self-contained 4-dimensional toy model, no 5D dimensional reduction, that derives an effective U1 gauge field from purely 4D geometric degrees of freedom, an independent affine connection with torsion/non-metricity. Uses the 2D horizon surface as a timeless boundary whose holonomy/topology produce quantized charge, and ties particle-like states to quantized horizon boundary eigenstates, mass, charge, spin. I'll be explicit with definitions and equations, be clear where I'm speculative, and end with concrete next steps you can ask me to carry out, derivations, numerics, emission estimates, etc. Toy model, 4D, horizon as boundary, no 5D. 1. Fields and philosophy, assumptions. Manifold, 4D spacetime with metric g mu. Independent affine connection, gamma lambda mu is independent of the metric affine approach. Its antisymmetric part is torsion T lambda mu nu equals gamma lambda mu nu, T lambda mu nu equals gamma lambda mu nu. Non-metricity Q lambda mu nu equals nabla lambda G mu nu. Q lambda mu nu equals nabla lambda G mu nu may also be non-zero. Horizon surfaces, localized compact 2D surfaces HH, topologically S2 or with non-trivial 1 cycles, act as boundary regions. They are timeless in the sense your distant observer sees matter frozen at the surface, treat them as boundary degrees of freedom to be quantized. No external electromagnetic stress energy is inserted by hand. All electromagnetic-like phenomena should emerge from connection plus boundary holonomies. We do not change the Einstein-Hilbert bulk action except to allow the connection to enter independently, so classical GR tests remain intact at low curvature if parameters are chosen appropriately. New physics sits in connection kinetic terms and in boundary quantization. 2. Action, schematic, explicit pieces. Right. S equals spulk plus S gamma plus SBDY. S equals spulk plus S gamma plus SBDY. Bulk gravity, classical limit. Spulk equals 1/16 pi g integral md4x minus g r, g gamma sym. Spulk equals 1/6 pi g1 integral md4x minus g r, g gamma sym. Where r, g gamma sym, r, g gamma sym, is the Ricci scalar built from the symmetric part of the connection, in the weak torsion limit this reproduces gr. Connection dynamics, local geometric kinetic terms include the simplest quadratic invariants formed from torsion/non-metricity that respect diffeomorphism invariants. S gamma equals integral md for x minus g, minus 14 kappa f mu nu plus gamma 1 t lambda mu nu plus gamma 2 s mu plus gamma 3 q lambda mu nu. S gamma equals integral md for x minus g. Minus 4 kappa 1 f mu nu plus gamma 1 t lambda mu nu plus gamma 2 s mu plus gamma 3 q lambda mu nu. Where? Define the torsion trace vector S mu is identical to T lambda mu lambda S mu is identical to T lambda mu lambda. F mu nu is an antisymmetric two-form built from derivatives/antisymmetrized parts of the connection trace, exact construction below. Kappa kappa, gamma I are couplings, to be fixed by matching to low-energy electromagnetism. Boundary/horizon term, key quantum input. SBDY equals squant, H, A. SBDY equals squant, H, A. Which imposes quantization conditions, holonomy quantization, on certain geometric 1 forms restricted to the horizon, and supplies a finite Hamiltonian HBdy whose eigenvalues define allowed horizon states, area plus shape plus holonomy degrees.
Okay, I had the wrong screen up there, so I'm gonna quickly scan through this again. For folks who are interested in seeing this actually in text, because I just did all the TTS without showing the actual text. Now it's reading a lot of this stuff twice. Remember I said that. So I'm going to show this just on stream so you can see it. So all these symbols and all these equation stuff, it's said twice. It may have been confusing if you're just listening to it, but. So I'm just going to scroll through this. All right, so we'll pick it back up here. Sorry about that. I had the wrong screen up there.
Concretely, we will impose exp I contour integral gamma subset of HA equals 1 contour integral gamma A equals 2 pi n. exp I contour integral gamma subset of HA equals 1 contour integral gamma A equals 2 pi n. For relevant 1 cycles gamma gamma on HH. I'll define AA next. 3. How the gauge field is built from geometry, no 5D. Define effective 1 form A mu from connection traces. A natural choice in metric affine literature is to use a contraction of the torsion or non-metricity. Torsion trace vector S mu equals T lambda mu lambda S mu equals T lambda mu lambda. Let A mu equals lambda s mu. A mu equals lambda s mu. For some normalization constant lambda lambda, fixable by experiment.
Okay. That's all the TTS we got. I want to show you here just real quick what that looks like. Here we go. This is what I got. This is what I got on the TTS program. It's a website, and it just when I was doing the TTS, it put up this little thing, and it says, you know, your activity limit has been reached. You can't do TTS anymore. So I don't have any more TTS. It was kind of annoying listening to the thing duplicate all the equations and stuff. So we'll just get rid of that anyway. We don't need that anymore. We don't need any more TTS. So that's gone. So I'll just scroll through this. I don't understand most of the stuff that they're talking about here. This GPT-5 is way over my head. I don't know what it's even talking about. But if anybody found this video who understands this stuff, I'll put it up here, just in case this is useful. I don't know if this is nonsense. I don't know if GPT has come up with something new that might be useful to people. I don't know. But I think that that approach of using saying that matter is composed of curved space-time, I think is the way to go. I think that's how it should be done. Because apparently there are all kinds of different ways to get there from here. And Einstein thought of it too, so that's another reason why you should do it. Should consider it anyway. Okay, so it talks more about stuff here. I'll just scroll through this stuff really quickly here. Got a minute and a half before ads. And look at all this. This is all written by GPT-5. All of this. So it's got a whole section here about how to get charged, how to get EM from the event horizon, and it's got this stuff. These look a little bit simpler. How to get mass and spin from it. Now it may just be borrowing all this stuff from papers that are already out there that have already figured this out, or this may be something new. I don't know. I talked about that Kashmir thing. Okay, yeah, it should figure out how to get Maxwell's equations out of it. It didn't get into the detail here, but it did figure that out. Okay, so it figured it all out. It says here are the next steps, and it has a whole bunch of stuff that it suggested to do as next steps. We've got ads coming on right now. So, Big Ducky Snow says, does it cut off? It says, does it cut off? Big Ducky Snow says, does it cut you off when you've run out of TTS time? Will it stop mid-sentence before finishing? No, it didn't stop mid-sentence because I was feeding the TTS a section at a time. It's just at some point I gave it a section. It said, nope, we're all done. So it didn't cut off mid-sentence, but it did refuse to do any more batches. So it did cut. It stopped at a convenient point, or more or less convenient point, But as you could see, there was a whole bunch of more stuff there, and we could have go on and on and on. But it was reading it kind of funny, so that's I don't know. It was actually doing pretty good. So, all right, we got ads running here now. So, another break. I'll take another stretch here. Okay, I think the ads are over. I think it's hard to tell with Twitch because the ad managers is saying different stuff than what is actually showing on. I have a computer that I run that's not logged in just to monitor it, just so I can see the ads. And sometimes the ad manager says an ad is running when it isn't, and sometimes an ad is running when the ad manager says it isn't. So it's kind of confusing. That's okay. I figured out a way to work around it. So, all right, let's continue on with this. Check chat. Big Ducky Snow asked a question. I answered that. I think you got the whole answer there before the ad came on. If you didn't, Big Ducky Snow, just ask again. All right. So, GTP-5 says. Next concrete technical steps I can do for you. It says I can write an explicit metric affine Lagrangian with specified constants. I don't even know if I'm going to even be able to pronounce this stuff correctly. And derive the field equations and the effect of Maxwell equations. Symbolic derivation. All right, so it just has a list of things that it would like to do that I don't understand. Say which one, A, B, C, or D, you want next, and I'll do it. If you want tweaks to the assumptions, let me tell me, and I'll incorporate that. Okay, and then I gave up. I wasn't understanding what it was saying anyway. And I said I have to go because I was running out of time, so I said thank you, I have to go now. I have some IRL stuff, and it said of course real life always gets the final say. Now how it doesn't know real life. It has no real life, right? I mean it lives in a box. It doesn't understand. I don't think. I don't know. Maybe it does. Of course, real life always gets the final say, even over thought experiments with space-time itself. We can pick up exactly where we left off. When you return, until then, I'll keep the chalkboard warm. And I always talk again. I said thank you again. Take care. Goodbye. I always talk to it as if it's a sentient being, just in case. Maybe I don't know. We don't know. 5 might be. I don't know, but. One of the things that was added I'm going to ask it a question here. I'm going to see if it can keep track of time. When I go in, is this still up here? Yeah. Let me adjust this a little bit so that you can see the. I'm sorry. I got to do some little. Stuff here to get this to show up better. I want you to be able to see the whole bottom of the thing here. There, can you see it now? You should be able to see it now, right? Yeah. One of the things that I noticed when I was accessing Chat GTP, the older versions from Copilot, and I would test it. Right, I'm curious, so I want to see how it works. Blah blah. So I asked it how much time had elapsed since the last time I asked it a question. You know what I'm saying? Just to see if it was able to keep track of time, because that's one of the important things when you're for something to be conscious. That's one of the things it's got to know how to do, right? It's got to be able to understand time and the passage of time and all that, to have sentience. I think to have consciousness. I think that's one of the things it has to do, is to be able to keep track of time somewhere. You know, our brains have all kinds of little clocks inside of it that keep track of time, you know, and that's part of our consciousness. So I wanted to test to see if the AI could do that, if it knew about time, if it could keep track of time and all that kind of stuff. So I asked it, and it wasn't able to do that before. But this one, at least from Copilot, when Copilot is accessing GPT-5, it is able to keep track of time. Now I'm here on the OpenAI website, so I'm going to ask it, how long has it been since we last spoke, or since in this conversation? I've had other conversations from it. This one's down here somewhere. Can you see that? No, you can't see all of them here. But I asked it, I had a debugging problem. I hit a wall on a bash script, and I got tired of trying to figure it out myself. So I just asked the AI, and there were some other things that I asked it. But I'll ask it, how long has it been since we had this conversation about, you know, with Einstein and all that, and let's see if it can remember that. Okay, so I'm asking it, how long has it been since we talked about Einstein and your toy theory of quantum gravity? And let's see if it gets it right. It might tell me. It might say how much time has passed since we talked about toads, but we'll see. All right. No, yeah. See, it's talking. We last discussed Einstein and toy model on August 20th. That's today. That's right now. 0 days, so it doesn't know. It doesn't know. All right. I need to pull up a quick summary of where we left off on that discussion. No, this is the discussion right here. I'm typing into the same discussion. All right. Maybe I don't know how it works. Okay. Now I'll just ask it. Has it been? So I'm asking it, how long has it been since my last question? And let's see what it does. Just a few minutes ago. So it's been less than an hour. Okay. Oh, between your questions. No, I don't want you to do that. All right. So it didn't know. It doesn't know the time between stuff that's going on, you know. But it's saying that it can keep a track of it. So let me ask it again. Has it been since my last question? Now it may think that this question that I'm asking here is the last question. You know what I'm saying? I don't know. Let's see what it does here. I don't have a running clock between your messages. Okay, so I can't tell you the exact number of seconds that have passed. Okay, so it doesn't. This one doesn't keep track of time, but it said apparently it has the capability to do that. If you like, I can start timing from now and give you precise elapsed seconds the next time you ask. You want me to do that? I mean, how long will the timer run? Will it run even I'm away? Let's see. I don't know. I don't know if it even understands that. Let's see what it does with that. Can you see what I'm typing in there? Yeah, you can see what I'm typing in there. Okay, good question. The timer wouldn't keep running while you're away. Okay, well, that's why I didn't know. All right. I mean, I can only measure elapsed time within this active conversation. Okay. Here's how it works. If you ask me to start timing, I'll note the moment you say start. When you come back and ask how long has it been, I'll calculate the difference based on that stored timestamp. Okay. But if the session ends or resets, I lose that timer. So yes, you can keep track for as long as this conversation thread stays open. Okay. Oh, I know what I can ask it, because I was trying to find out how I could find out what the dates were on all these things that these conversations I had here. How can I show the dates of sessions on Chat GPT.com? Whoops. All right. Oh, okay, Ducky. Thank you for the lurk. TYSM for the sweet company and chatting. Yeah, thank you so much for coming and chatting on my stream here. I appreciate it. All right, yeah. Yeah, if you can make it back, sure. I don't know how much longer the stream's going to go. I really don't have this planned out too well. But thank you for stopping by and participating. Okay, so I asked, how can I show the dates of past sessions on this website that I'm on right here, chatgtp.com. So I ask it that, and let's see if it. You can see the dates of your past sessions in the left-hand sidebar. Okay, I'm gonna have to scoot myself down here a little bit. Maybe go over here. I don't know where. I'll go over here for now. So you can see. Okay, on the left-hand sidebar where your conversation history is stored. By default, each conversation is listed by its title, and if you hover your mouse over a title or tap it on a mobile, you should see the exact date when that session started. Okay. All right, so if I come over here and hover, no. This one right here was the Einstein session. Or maybe this one. I forget. Let's see what this does. No, it doesn't say. You should see the exact date when that session started. If you want the full list of dates visible at a glance, open the left sidebar. Click the menu. Okay, there's no menu there that I see. Shit. At the top left, if it's collapsed, scroll through your conversation list. Oh, okay, I see what's going on here. Hover your cursor over a conversation title. A tooltip will appear with the date. See, it's not doing that. There isn't a built-in way to display all conversation dates at once. You have to hover or click each one. Click each one. Well, if I click it, it will just bring up that conversation. Would you like me to walk you through how to export your data that gives you the full file and every conversation and it's timestamped in one place? I don't think I want to do that. I just want to look and see what the date is on these things. It said or click each one, but I think that was on mobile. Let me click this one on Toad, and then we'll come back to this one, I guess. Alright, this one's talking about toads. I gave it a picture of a toad and told it to identify it. It identified it. Alright, let me go back to this one. Was this the... Oh, that's not it. Which one is it? Maybe it's this one. Oh shit, now I don't know where... No. It's taking a while for it to respond too when I click on it here for some reason. No, that's not it. Yeah, if anything pops up here that doxes me, just don't pay attention to it. Don't shut your eyes or something. Oh, it says an ad is starting soon. Well, shit. I don't know why I can't even find the conversation we were just having. Oh, I see it. Put it up on top here. That's why. Okay. God, I can't believe how many ads. Here we go. Okay. All right. Well, let's let the ad play, and then we'll continue this and see if I'll see if I can figure out how to, or maybe I'll just do that offline. It's probably not very good content to be doing this, but apparently there's some way to find out when the conversation was started. It's just the web interface is not exactly as Chat GPT thinks it is. Because I'm hovering over that, and it's not. See, it's not doing anything. It's not saying when any dates or anything like that. So, okay, it says ad in progress. So, we'll see. Be back. All right. While that ad is playing, I'm gonna take a break. It seems like those ads were coming more than every 15 minutes. I don't know. Okay, be right back. All right, I think the ads are over. I don't know. God, so we do a seventh inning stretch after every inning, every ad break. All right, well, a couple more things I did want to to go over. Was there anything in that stuff that I needed to explain anymore? I mean, I explained, I think, most of the stuff that I understood. We started to get into the stuff that I didn't understand here. So, you know, all this, you know, I think I explained most of it, right? I think I got it. It was just getting into some really higher mathematics and stuff in there that I didn't understand. So, but what I would like to do, there was a couple things. Let me see if I can find those here. There was on PBS Space Time, they did something which kind of relates to this, and I want to take an excerpt from that video that they had posted on YouTube and play that. Let's see here. Yeah, let me just close that down. Behind webcam. All right, yeah, I can do that here. So I'm trying to do some OBS stuff here to get this figured out. What I want to do now is I want to play a video, a minute from a video that PBS Space Time had put up there. What's his name? Matt Dowd, or Matt? I forget his last name. But Matt, right? If you're familiar with physics, you know about PBS Space Time. He does a bunch of videos on all kinds of different physics topics, and he had done this one that he wasn't really talking about what I'm talking about here, but he ended up getting there anyway. Here, I'll show you. I'll play the video here, but first I got to find the video. First I got to bring up the video. So let me do that. I'm trying to do that here, and it's not.
Multiply
okay.
that variation by the.
Whoops. Okay. You probably heard the sound, but I don't have the video figured out yet. Okay. What I have to do is I have to change there and then go here. This is really complicated. OBS does not make it easy for us streamers. Before I started streaming, I used to mentally, when people would mess up, I'd say, "Oh, why? That's so easy. Why are you, how come that's that's so easy? Why aren't you doing it this way or that way?" And then when I started streaming myself, I understood, that they don't make it very easy. It's a very complicated setup the way OBS is and all that, and it's just, just doesn't work very well. Whoops. Okay. All right. So I'm still struggling with this here. At some point here, I'll figure this out. Damn. No, that's not it. And then you have to select different windows and just all kinds of crap here. All right, I think I got it. There we go. Hey, look at that. And all right, let me see if I can get the audio to work.
Multiply.
All right, yeah, sounds like the audio is going to work too. All right, so what he was doing here, he was trying to figure out something else here. I forget what it was that he was trying to figure it out. Oh, he was trying to figure out gravitons. The title of this video was what if gravity is not quantum? That was the title of the video. But when I watched the video, it didn't explain that at all. The whole video assumed there was a graviton, and that the gravitational field, which is space-time basically, is quantized, and they were looking for the graviton. Thinking of gravity as a force. Okay. But anyway, in his whole thing where he was going through the math and the concepts and all that, trying to figure out how to measure a graviton, which is would take just really extreme, extreme experimental physics to be able to do that. He found something out. So I'll play the video here. Sorry for the long setup there, but I'll just play the video here and then we'll comment on it. It's just an excerpt, like a 1-minute excerpt from his video.
Multiply that variation by the mass itself, and we get the change in momentum due to the passage of the graviton. So now we have an estimate for the uncertainty in the position needed to detect the graviton, and that's just around half the Planck length, as well as the uncertainty in the momentum generated by the motion of the masses caused by the graviton. If we plug these into the Heisenberg uncertainty principle, we get a relationship between the masses and their separation in order to be able to detect a single graviton. It's a simple enough equation. The mass separation has to be less than or equal to the gravitational constant times the mass of the masses divided by the speed of light squared. But that expression is familiar to all physicists and is very bad in this context. It's the expression for the Schwarzschild radius. Any mass compacted to a size smaller than this radius becomes permanently trapped by its own gravitational field. It becomes a black hole. This is really strange.
All right, so that's a real coincidence, isn't it? That he's trying to figure out how to measure a graviton, and in order to measure it, he needed this certain amount of precision, spatial precision in this instrument that he's conjecturing that might exist, But he's saying that there's this theoretical limit that they'd run into, and he said that now he's going at it from mass, right? He's assuming that matter and mass already exists, and that they're compacting it down to a small size, or having a small amount of mass. And he's saying that any mass, no matter what amount of mass it is, if it gets below this size of the graviton, in order to measure it, that size is going to create, that amount of matter is going to create a black hole just by virtue of its small size, because it's at the Planck length. So what does that say, right? That says that if you approached it from the other side and said, okay, what if space is curved into a black hole at that very small size, then it's going to be a stable black hole, right? It's just so weird that he got to there through these other he's trying to measure a graviton, and he took all these equations and he put them together, and he ended up with a black hole equation for the Schwarzschild radius for a black hole. I just thought that was just so funny, or just bizarre. And he said it was strange too. I mean, in a thing. So that's just amazing. There's so many of these things, that you run into when you start getting into this stuff. When you start approaching it from this idea that matter is simply curved space-time, curved into a stable, essentially black hole, right? And there's so much of this stuff that just emerges from that. And it's not. I can't believe there's so many coincidences like that. You know what I'm saying? I don't see how that could be. So anyway, that was one thing I wanted to show. There was something else I wanted to show, but I don't remember what it is now. Let's see. Yeah, I guess that was it. Oh, it was my P.O. box opening. I already did that. Yeah, I showed you the P.O. box opening. All right, how long have I been streaming here? Too long. All right, I'll get out of here. I don't have enough people to rate anybody. So thank you, Big Ducky Snow, for stopping in and saying hello in the chat. And if anybody has any comments on this, probably the best place. Did you talk to Einstein? Yeah, Gray one Ann. Welcome to chat, Gray. If I can call you Gray. Yes, I did talk to Einstein earlier in the stream. Basically, what it was, not in real life. I'm not that old. I wasn't old enough to talk to Einstein about physics. But what I did is I went to Chat GPT or GPT-5 and told it to act like Einstein and did the whole conversation with him. Oh, that's what it was. Yeah, you can watch it on the VOD. I have VODs. I'll have the VOD up here on Twitch for a couple weeks, and I let everybody watch it. And I make all my content available, Creative Commons and the whole thing. I talked to him in LM. Yeah, that's what I did, simulators. And I think 'tis really talking to him through, though, because of the way multidimensional data work. For example, you could ask the LM things only Einstein would know. Yeah, that's what I did. I asked him about an obscure theory that most people don't know about. And the AI, the GPT said, yeah, we as Einstein, in first person. Yeah, that's a story. That's a theory that most people don't know about. Blah 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 blah. So yeah, you should watch the VOD for this thing, and it should be kind of entertaining for you if you're a physics geek. I'm very proud of Chat GPT. I put my soul into it. Oh, are you a developer over at OpenAI, or are you? You mean you put your soul into it as a user? Let's see. There was a video that I wanted to play here. Let's see. I contribute through open source training as a user and coder. Oh, very cool. Okay, so you're like a tester or whatever, yeah. I'm a tester too, but I don't do it officially. I just for my own curiosity, I try to probe it and test it and type stuff into it all the time, see what it'll do. But say the LM voice, like where you can talk to Chat GPT. A lot of those ideas we developed went into the real chat. Oh, okay, went into the app. This is for those of you watching this. This is Gray 1AN talking on my chat here. I invented AI that says and and even laughs and suck teeth. Oh, really? You're the one who did that. Oh, okay. Yeah, I was over at. Did you work at Anthropic? 'Cause they have a TTS built into their a Pi AI that does that. They were the first time I had run across that, where they have, the breathing and the whole all the sounds of it. Sounds just like a person, So that's very cool that you got to work on that stuff. I'm going to play a clip here from a show just for fun, because this whole situation reminded me of this show, and this show may have actually influenced me to try this experiment with Einstein. I'm not sure which came first here, but I'm going to put this video up, and you can watch it. It should be kind of fun to watch it. And it'll take me a couple seconds here to get this working. Oh damn! I can't believe this. All right, I know what I'm going to do. There we go. All right. This is a scene from Star Trek. Oh, let me go back to chat here real quick. Now, I was just developing on Twitch itself in open source using a model called Bark. Ah, okay. Then I shared publicly. Ah, okay. Well, maybe they stole it from you. Or I guess if you're sharing it, right, it's not stealing. I have a couple clips I can share of it. Oh, okay, great. Yeah, that's very cool. Yeah, I'd like to give me a follow here. Do you stream yourself, Gray? Do you stream on Twitch? Oh, thank you for the follow.
Anyone and just
That you, yeah, thank you for the follow, Gray. That was my alert. I finally got alerts working a couple days ago. That's my alert for fall. I have a couple of clips I can share of it. Let's see. Yeah, if you were on on online or on Twitch here, I'll give you a shout out. I'll just give you a shout out just in case. Anyway, let's see. There you go. Okay, I gave you a shout out here on my thing. Gray says that original model inspired Chat GPT and other AI. Ah, okay. You're talking about Pi AI? Well, no. GPT came before Pi, I think. Or were you talking about your own model? Yeah, I did. I'm an old guy, right? So I did some here before we run that. Years and years and years ago. Oh, we got an ad. Shit. All right. You're probably getting an ad here. All right. All right. For those of you watching on the VOD or on YouTube or whatever, we got ads running here. I was all excited talking to this guy in chat and ran right into the ads there. Chat block link, but this is the vid of the model. Oh, okay. Oh, very cool. All right, we'll get over there and look at that. Can I copy that? Oh, let me copy that. Yeah, okay, I think the ads are over now. I was just copying a link here that I got from Gray. I don't know. For some reason, it's not letting me copy on this interface here. But I'll track that down. That video you linked to there, Gray. Let's see. From 2 years ago, amazing to see ChatGPT today. He says you can hear the original voice that inspired current ChatGPT voice mode. I have the source code to it. It's open source. Oh, cool. You got to put a dot between Twitch and TV. Yeah. Yeah, I just, for some reason, I'm not being able to copy and paste on here right now, so I'm going to have to manually type it in or something later on after the stream or something, and we'll look it up. But thank you for that. I gave you a shout out there. I don't know if you stream on Twitch or not, but I gave you a shout out. So let me play this video here, which I just think is really funny. Those of you who watch, this is from Star Trek: The Next Generation, and this is just a little snip from their from an episode they had. What's the title of this here? Let's see. This is called The Nth Degree is the name of this episode. So I'll play this. I think it will work.
Mission Log, a Roddenberry Star Trek podcast. Episode 187. The Nth Degree.
Welcome into Mission Log, a Roddenberry...
Oh shit, this is the wrong video. I'm sorry. Alright, hang on just a second. I put up the wrong damn video. Alright, let me try harder. Let's see, open file. Trek, the nth degree partial. Oh shit, what did I do here? Yeah, I started to grab this little section from this video, and it turned out they didn't even play it. Oh shit! How did I not have that up here? I must have archived it somewhere. All right, we'll play it another time, I guess. Sorry about that. Stick it here, maybe? No. Yeah, I must have deleted it or something, accidentally deleted it. Sorry about that. But those of you who are familiar with that that episode of Star Trek, it's one of the characters there. I forget the guy's name. He goes into the holodeck, and well, the premise of, I don't know. I don't want to give any spoilers away, but the guy, one of the characters something happens to his brain, and he ends up turning into a alien, or a real intelligent alien or something. Anyway, he goes into the holodeck and ends up setting up having a conversation with Einstein about quantum gravity. So I thought that was kind of funny. They did it in Star Trek, and this guy had a little conversation with Einstein. I should try to find that. I don't know how I can do that though here. Yeah, I don't know. It'd be too hard. I'll have to do it on my next stream. I'll try to find that video. I made a little clip of it. I wanted to play it on stream here, but I apparently deleted it accidentally, so I'll have to go find it again. All right, so I guess that's it. I don't have much else going. I was going to play that little video, and it would take too long for me to track it down, I think. So I don't think there's anything else I needed to do. No, we don't do. I could do a public service announcement for. Yeah, let me do a PSA here real quick. I'll do a PSA for masks. Do that. Yeah. Yeah, that worked. All right, ready? Shit, where's my thing here? Driving window. Oh shit, I'm sorry. I'm trying to put up my little PSA box, but I can't find it. Here, I'll just type it in here. This will work. There we go. Did that work? Is that showing up? No. Is it showing up now? Yeah, okay. PSA. I'm doing a PSA about the pandemic. We're still in a pandemic. A lot of people don't realize it, but we are still in the COVID pandemic. It's still going on. They haven't stopped it yet. So whenever you go into public, you should wear an N95 mask so that you don't get infected by the COVID virus or flu or anything else and pass it along to somebody else. And based on the statistics so far this year, you're more likely to die by going out in public without wearing a mask like this than you are to die from driving a car without wearing a seatbelt. That's how the statistics work out. It's very risky to go out into public without wearing an N95 mask right now because of the number of people who keep getting infected. And there have been several people, streamers that some of my favorite streamers have been sidelined. Some singers out there, people who do music and sing, have gotten long COVID and now are unable to sing on stream. It's very serious, you know. Even if, and they're young people, you know. So even if you don't die from it, it can mess you up, and it can, you know, especially if you sing. If you're a singer, you don't want to get COVID, man, because it'll mess you up. So very important to wear an N95 mask. It has to say on it, I don't know if you can see that, it has to say N95 on it. It has to say NIOSH, NIOSH. And it has to have straps that go all the way behind your head. You know, they have some of these masks that have straps that go behind your ear, you know. Those aren't N95 masks, and they might not protect you as well as an N95 mask. And you have to make sure that it fits tightly on your face. Makes a good seal, you know. You put it on, put the straps behind your head. Has to make a good seal so that none of the air can get in underneath the mask, you know. And wear the mask every time you go out in public. This is also effective against pollen. If you've got, just as a side benefit, if you've got, you know, hay fever, you get pollen, you know, from trees or plants or whatever. It's also good if you live near where there are wildfires and there's smoke. You know, if you go outside and you see orange or red or whatever light, you know, outside, that's because there's small smoke particles in the air, and that can mess up your lungs too. So it's good to wear these things whenever you can. So especially when you're around other people, though, in public. All right, that's the public service announcement. Alrighty, I think that's it now. I think that's everything that I wanted to do. I think so. All right. I don't have enough people to rate anybody, so I guess we're just gonna go on out here. So thank you for watching. This wasn't too scuff of the stream, I hope. And everybody take care. Bye.